Today we are going to talk about 3D meshing, and today's focus will be on the more manual side of 3D meshing. Next week we'll go into solid mapping, which is more of a semi-automated tool to help. But there's always these cases where we might want to go and just quickly manually alter a 2D mesh and create a 3D mesh. So I'm going to open today's model file, and I will send this out after this arm brackets, and it's been recolored just because the original colors that were chosen for this model were kind of bad. Just taking a look at what's in the model, it is surfaces, and they are sorted into 4 components: a base component, this curved part of the arm, a straight portion of the arm, and the boss piece. For the manual 3D mesh, a lot of these tools have not been migrated over to the new user-friendly tools up here, so we are going to be working in the panels for now until these specific tools get migrated over. We'll be in the 3D panel, and the tools for doing this are going to be grouped over here. We'll start off, I'm just going to hide some of this stuff for the sake of simplicity and start over here on this base piece. You'll notice it's bolded, meaning it's the current collector. So anything we make is going to go directly in there. We talked about this 2D auto mesh. So we're going to select the surfaces we'd like to mesh to basically make a template for the 3D mesh. And you'll notice there are, by default here, some tria elements. Let's go ahead and put them to just be quad only. And we'll go ahead and accept that. That'll be good enough for what we're doing today. One thing to note here is the element density along here. As we're making this, the density and the element spread of these components is going to be important. Once I have this base 2D mesh, if I just want to mesh this component, I can almost just extrude these elements or pull them back, drag them backward. It's not that there's only one tool to do all of these. In some cases, I'll just choose, for instance, in this case, drag, but there are other options here that would have accomplished the task equally as well. So by default, you'll probably come in here to the geometry. We want to be in drag elements. We're going to select the 2D elements here. Not sure why the visualization's not working. There we go. And then we can either specify a distance and a direction with nodes or with the global axis, but what might be easier in this case is just to say drag from node 1 to node 2 and automatically calculate the distance. And it will do this in the correct direction. And we want 5 elements as we drag along here. We could, of course, change this. And instead, let's reject this and drag in the minus direction. Now we have our elements, our 3D elements here in the base surface. Let's not forget, we'll keep it in the back of our mind that we do also have the original 2D elements that we used. Let's make this curved arm the current collector so that what we create will go in here. In this case, I want to be able to either spin, so that's one possible option, is to define the center point and spin these elements around. But that does require me to have a center point, easy enough to do in the distance panel. But I wanted to show off a different tool since some of us may already be familiar with spin, and that is going to be this line drag. In order to use this, we're going to specify the elements we want to drag. It'll be outlined here in this L shape still. And the easiest way for me to select these elements is just going to be, oops, Let's reset that. Just clicking here, and it'll select anything in this window that I create. And then we want to tell it what line to drag along. This is a curved surface. We can just select one of these lines, and then we tell it how many elements we want along this drag. 24 is the last thing that I used. That seems reasonable, so we'll try that again. And now we have created lines that are dragged along here. Again, we could have also just spun these in a circle using that spin tool. Moving on to the arm straight point, we are going to make this current, so our elements go there when they're created. And I'm going to show the linear solid tool. So that's this one, and it kind of prompts you for what information it wants. So in this one, we're going to be mapping from some set of elements to another set of elements and giving this some kind of alignment to line up appropriately. So we do, if we're going to map from here to here, need something over on this side. Go and mesh this side appropriately so that it matches the number of elements over here. Mesh these. We're going to keep that same mesh size of 10. But you may remember, or you can see here, there's, for instance, 3 elements along the length on here. So we're going to match this up so there's the same number. And I know that there are 8 elements along here. When you want to select another edge, you can simply left click somewhere else. It'll turn off your current selection. So let's bump this up to be 4 elements across there. And now we should have a matching number of elements, and we can simply match element 1 here to element 1 here and so forth. All right, one thing you'll notice if I try and just go do this as is that I cannot select these 3D elements. Actually, I can select them, but what I usually do is go and create a 2D face here. If I select this component, say find faces, I get a 2D face. You'll notice this caret, meaning it's not something that's going to be exported. It's more just a temporary component to work with. From doing this, I can come back and go back to linear solid. This allows me to just simply come here and select this by face. And then I want to select these. Maybe I'll select these by collector. They're the only thing in this collector. So this is going to be the arm straight. And then I have to tell it how this element's aligned, or how this generally is aligned. So this portion here goes here, and this goes straight, and this goes straight. Density, that's just going to be the number of elements along your path. We're not going to have any kind of biasing here. It'll just be evenly spaced elements. We've already made this our current collector. We'll hit solids, and now we've got these 3D solids that have been made. Lastly, we'll make the boss portion of this current. In order for this to work well, we're going to mesh the bottom of this and essentially do a glorified drag upward. But we need this component and the 2D template to be aligned with the elements that are already there. So we're going to put our surface mesh on, and this has been nicely divided, so you can see that you've got 4 elements here and 4 elements here. And we're going to want to match that up. Keep that mesh size at 10 since it's what we've been using. And we notice this isn't the most beautiful mesh, but more importantly, it's also not lining up with these elements over here. So there's 4 here, that's good. Let's go ahead and bump this up to be 4. And we're trying to get a hexa mesh here. So in order to get rid of some of these transitional triangles, let's go ahead and select all of these and also set them to 4. So now we end up with quads only, and we'll want to align the other side to make it nice. 4 times 4, 16. And we'll want to get rid of that tria, also make this 16. We have both just quads and things are lined up as much as we need them to be. From here, we're going to use this solid map tool. We'll stick with the general. We're going to just drag these elements, so we'll leave the source geometry blank. There's of course other options, but we are going to select these by face, specify our destination surface up here, and we want this to move along this line, but we also need these elements to be matched up with the elements that already exist on the side. So we're going to specify a node path that runs along here, and then click and drag, and then we'll make a temp node that's aligned over here. The element size, again, still going to be 10 since that's what we've used all along. Hit mesh, and now we get this last piece 3D meshed. You'll notice, unfortunately, that it went to this solid map term, but that's easy enough to fix. We're just going to go to Assembly and Organize. Component 4, and select the elements by solid map. All right. And now they've been moved to solid map. Other things we want to do here, we have those 2D elements that are still templates and kind of from the intermediate stage. We will want to get rid of those. So let's go ahead and just select all of them. We're going to select elements by configuration, and we can get rid of all of the C-quad 2D elements by selecting them, hitting the delete key, and now they're gone. I personally know just from demoing on this model that faces and solid maps should now be empty, but if we didn't necessarily know that and wanted to just do some general cleanup, we can go to validate, ask it to find empty components. You'll notice that faces and solid map shows up. We can delete them, and now we're left with our original 4 components. One final thing that I like to do, especially because it's easy to get lost in all the maneuvers here without making sure that everything is connected, is go over here to Tools, either Faces or that Edges should be fine. Select all of my components. And then set this tolerance to be very small. The element size is 10, so I'm going to set it to 0.1. And this is just going to tell me if these nodes are sitting very close to each other within 0.1, but they're not connected. And of course, I'd like forces to be transferred through here. So I want my elements to be connected in this case. Let me preview the equivalence. And I see that right here, these nodes are not connected. So I will just equivalence them. And now this node is connected in the orange color to this node on the blue part.